Hi everyone, so now what we're going to be doing in this little recording is I'm going to record topic 2 part 3. Now this topic 2 part 3 is going to be split up in a series of recordings, so it's not going to be all in the one piece, just to let you know, because there's a lot in this kind of section. Okay. So don't forget, here are our subject learning outcomes and here are our learning objectives. And these are the learning objectives are what we're going to use to drive or design our questions for you for your assessment tasks. Okay, so we are going to think about mixtures in this recording and the different types of mixtures, and we're going to look at that. And we're also going to think a little bit about how important water is, because water is it's called the universal solvent because it's so common, and our bodies consist of mostly water. So we are made of water and things dissolved in water. So water is our major solvent, okay? So water is very important for the integrity of our bodies, and make sure you're drinking lots of water every day. Why is water so important to us? We already saw water. You know how there's a V-shaped molecule and the electrons hang around one end more than the other end? Yeah? So because of its shape, the water has unique properties, okay? So let's have a look at those properties. Water is really useful because we can actually dissolve other chemicals in it, okay? Just like you would put a teaspoon of sugar in a glass of water, it's exactly the same thing as what happens in our bodies. The good thing about water is that it also adheres, it's good for adhesion. So it clings to a lot of different things. So that's quite useful, and we're going to see more examples of that later. Water is useful because it also clings to itself, okay? Now that's going to be useful again. We're going to see examples of these. Water is involved in lots and lots of chemical reactions in our bodies, okay? And we also make water ourselves, okay? We're going to see lots of examples of that later. But just so you know, that water is involved in many, many chemical reactions. And the good thing about water is that it's very stable. It doesn't change temperature very quickly, which is really, really good, okay? Because what we want to do is we want to keep and maintain a stable internal environment. Now, what's that word that we use to describe a stable internal environment? It is homeostasis. I hope you shouted it out to the screen. And I kind of feel like a YouTuber right now. Okay, so let's have a look at water. So if something loves water, okay, it's called hydrophilic, okay? And that means that it's a substance that can dissolve in water, okay? If something hates water, we call it hydrophobic, okay? So for example, oil hates water. That's why they don't like to mix, okay? Sugar loves water. It actually mixes in really, really well. All right, so let's have a look at a few different mixtures. So what is a mixture? In our last recording, we looked at things, atoms that can be joined together by chemical bonds, okay? A mixture is something different. A mixture is where we have atoms or molecules in the same area, but they are not joined by chemical bonds, okay? So here we go. So mixtures, you can have solid, liquid, and gases. See that? These ones are joined by chemical bonds, yes, but these ones aren't. That's the difference. So you need to make sure you understand the difference between whether atoms are joined together by chemical bonds like this versus a mixture where we just add in everything together, but this one and this one is not joined by chemical bonds, is it? They're just hanging around in the same space. So that is what a mixture is, okay? Not joined by chemical bonds, just hanging around in the same space. Right, so there are 3 types of mixtures that are going to be useful for you, for your learning and also as a health professional. The very first type of mixture is called a solution, okay? And a solution contains 2 different things. It contains a solute and a solvent, okay? Now, here it is. The solute is what you put into the solvent. Solute plus solvent equals solution. Easy as that, okay? Now, can you see that if we put a sugar cube into water, eventually you won't be able to see the individual sugar molecules, can you? It all looks the same. So when we look at something and it all looks the same, we say that it's homogeneous, okay? So a solution is putting a solute into a solvent equals a solution, okay? The solvent is usually water in the body. Right, let's have a look at this now. This is at the other end of the spectrum. This is called a suspension. So if you put solutes into a solution and the solutes are really, really big, you can mix it up, that's fine, but after a while it will settle out, okay? So that is a suspension. Suspension means you've got big solutes, big molecules into a solution. And you can mix it in, it'll stay mixed up for a while, but then if you leave it there, it will all settle down the bottom. Some medicines are suspensions. Here is some more information about suspensions. So see here in a solution, the particle's only very, very tiny. So when it's floating around in the solvent, you can't see it anymore. It all looks the same. Whereas in the suspension, see how the solute is big? Yeah. So that's essentially, the solvent stays the same. It's just the solute that changes between the different mixtures. And this is a mixture that's in the middle, okay? So what this one describes, okay, let me just go back a sec. So we've got, so in a solution, the solute is tiny. In a suspension, the solute is big. In a colloid, the solute is in between in the size. Pretty much that's all it comes down to. Size of the solute, because the solution stays the same. It's usually water. Now this one is a type of colloid. So up until now we looked at solute going into solution. Solute going into solvent. And it's always the same. For the 3 types of mixtures, you've got a solute going into a solvent. In this instance, in an emulsion, what you have is a liquid going into another liquid. Okay? So you don't do solute into solvent, you go solvent into solvent. That's the difference. And because sometimes they don't mix very well, you need to add stuff in there that allows it to mix. And that's what a detergent. So let's summarize what we've done thus far. We know that a mixture is a combination of elements or compounds or molecules that are put into the same space and mixed up. But these elements or molecules or compounds are not stuck together by chemical bonds. They're just mixed together in the same spot. And we know that there are 3 types of mixtures. If you have a look at the size of the solute, you've got a solution has the smallest size, colloid is the next size up, and the suspension, it has the biggest size of solute. The solvent, usually water. If you look closely, can you make out the solute floating around in the solvent? If you can't, then we call that homogeneous mixture. If you can, we call that a heterogeneous mixture. So that's what those 2 words mean. Now, if you let a solution sit for a while, it won't settle out. If you let the colloid sit for a while, it will eventually separate into solute and solvent. Same for a suspension. So that is mixtures.